Hey everyone, it's Mrs. Shannon, and we're going to do the Cycles of Matter screencast. Please take notes. If you haven't already picked up a note sheet, please pick up the note sheet so you can fill it in as we go through. The first time that we go through it, you're just going to be filling in the blanks as we go along. But don't forget at the end, you will be writing a summary and then going back and answering the questions. Okay. Once again, we do these screencasts so that way people can go at their own pace. Take advantage of this. Stop it, pause it, rewind it if you don't understand something. And please ask questions in class or send me an email if you have any questions about it as we go through. So this is going to be focusing on the cycles of matter. We've been talking about energy flow. As energy starts at the sun, the producers use photosynthesis to transform it into a usable form of energy stored in bonds of glucose, and it passes through the food chain and up the energy pyramid. We've talked about that. Energy flows through an ecosystem, but it can't be recycled. You can't use the energy again once it's been used. Matter, on the other hand, it can be recycled. And so they call it a cycle because it's going to go through different forms and it can move all around the ecosystem. And so what a biogeochemical cycle is, and this is going to be where the notes start here, is the movement of a particular chemical through the biotic and abiotic parts of an ecosystem. So between the living, biotic, and the non-living, without life, abiotic. Another way to think of it is biogeochemical. We're talking about the prefix bio meaning living, geo means earth, and chemical means element or matter. So when we're referring to these cycles, we're going to talk, and you'll hear this come up over and over. There's a few elements that are characteristic of life. Schnapps is a mnemonic that we'll talk about more when we look at biochemistry, but it stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And these are 6 elements that are found in living things and are necessary for living things in different biomolecules that are found within them. Now, remember from from middle school, that matter is anything that takes up space and has mass. So it's anything made of elements, it's got molecules, it's the atoms. And how these come together and arrange themselves gives us the different substances. And so if you remember talking about the periodic table, this is where we find many of our elements. We can even break this down. 65% of our total body weight is oxygen. And so oxygen and carbon are probably the most well-known. Hydrogen and nitrogen are often frequently known by students too. Calcium you hear about, like with milk, for instance, phosphorus, potassium. So you've probably heard about a lot of these elements. You may have seen them in vitamins, but they are necessary for us to be able to function, or any living organism to function. And they are elements that come together and can be cycled throughout the ecosystem and are found in different forms in different parts. So we're going to start with one of the cycles, the carbon cycle. The carbon is a molecule that is very stable. It can form a lot of different compounds, and it can be found in different forms depending on which part of the biosphere it's found in. The carbon cycle moves from carbon dioxide, which is called CO2, which is found in the atmosphere, through the food web, and then it returns through the atmosphere. And you know what? I'm going to try to make this a little bit bigger so we can see it. And so here we have, and it's backwards. But up here in the top, we have carbon dioxide. The plants use carbon dioxide in a process called photosynthesis. The carbon is then stored within the plants. Animals eat the plants. Sometimes the plants will die and decompose. The carbon is going to be returned to the atmosphere through cellular respiration. It can go through the water as well. It's in a different form, carbonic acid, when it goes through it. But it's going to be able to be cycled over and over and over again. The important thing to remember is that carbon dioxide is taken in via photosynthesis and released via respiration. Volcanoes are a natural contributor of carbon dioxide to the atmosphere, as well as burning of fossil fuels. So when you're looking at like pollution, for instance, it's a contributor to carbon dioxide levels. And sometimes you'll hear about that in terms of greenhouse effect, which we'll talk about later. Okay, so this one is flip-flopped a little bit, so we can actually read it here. But here you can see the carbon dioxide in the atmosphere coming in through photosynthesis. We have the consumers that are consuming the plants. Through cellular respiration, when they exhale the carbon dioxide is released back into the atmosphere. If these organisms die, either the plants or the animals, they can break down, decomposition happens. Again, we have like bacteria or fungus and cellular respiration occurring, and it's going to be released back into the atmosphere, and it can go again and again and again. We have another cycle that's common called the water cycle. The water cycle is probably the first type of cycle that you learned about. It's essential to all organisms. Organisms all have bodies that are made mostly of water. So the water cycle is also called the hydrologic cycle, hydro for water. It, again, is a cycle where it changes form, but it can be returned to different parts here. It moves by the process of evaporation, transpiration, condensation, precipitation, and movement through surface and groundwater. 97% of the biosphere's water is contained in the ocean, so the majority is marine. 2% in glaciers and polar caps, and only 1% in lakes, rivers, and other freshwater sources. Let me see if I have one. Yeah. And so here you can see the precipitation coming down. It percolates, meaning that it like drains through the soil. It runs off to the ocean. It evaporates from the ocean, and it goes back up here. Now, it can also transpire from the land when it goes directly from like leaves, from the leaves of the plants straight up to the atmosphere. So there's different forms that it can move in. Nitrogen is the third cycle that we're going to focus on. Nitrogen is a component of amino acids, proteins, and nucleic acids. These are three of our biomolecule groups that we'll be talking about. Most of the nitrogen cycle happens underground. Nitrogen fixation is a term that we're going to be talking about. It's where bacteria converts in the soil, or sometimes the plant roots convert the nitrogen into ammonia. The ammonia is released into the soil, and there it's transformed into ammonium. And then we have a different type of bacteria, nitrifying bacteria, which changes it into nitrate. And then this nitrate is able to be used by other organisms, other plants, for instance. Let me see if I can. Sorry guys, a little technical difficulty. I was hoping that I can move. There we go. The decomposition returns the nitrogen to the soil. And then the nitrogen is able to be taken up by the plants, and the cycle begins again. So the key here is that it's most of it occurs in the soil. It needs bacteria to help it break down into a form that can be used and reabsorbed by plants. So here you can see nitrogen in the atmosphere. There's also nitrogen in the plants. Okay, it's going to be used through nitrogen-fixing bacteria, nitrifying bacteria. It's going to be put into a part that can be taken, or put into a form that can be taken up by the plant roots. So how do humans influence the cycles of matter? Well, water withdrawal from the lakes and streams will affect the water cycle. When you clear vegetation, forests, and other plants, it's going to affect the carbon cycle through reduction of plants that can participate in photosynthesis. It also changes the landform over, and so erosion may alter like the percolation and the runoff for the hydrologic cycle. Okay. It also clearing some of that vegetation may also alter the soil components, and so the nitrogen cycle may be adjusted as well. When we fill wetlands, we're again altering multiple cycles. Burning fossil fuels and wood, big contributor to the carbon cycle. Farming, agriculture will contribute to all cycles, especially the nitrogen cycle. Runoff of animal waste, fertilizer, sewage treatment, water cycle, nitrogen cycle, you name it. So any questions? If there are any questions, you need to make sure that you send me a message or post it in a discussion. I'm going to have a discussion up in the discussions tab on Canvas that you can ask questions there. What next? Make sure that your notes are completely filled in. I also want you to do this. We haven't done this before. I want you to identify important vocabulary. When I say important, I mean anything that you feel is something that you need to know, or a vocabulary word that maybe you're not sure about, or that just sounds cool to you. So if you could go back through and circle any important vocabulary words, that would be great. And when it says to write questions in the margins, it has questions for you. You're going to write the answer to these questions in the margins. And then finally, write a statement of importance, which is a summary. If you need to rewatch it, please do. We will have a follow-up in class activity as well as watching an ed puzzle to help kind of reinforce the idea of the different cycles for us. But the takeaway here is that there are multiple ways that elements and matter can move through the environment. It might change the form that it's in, but it can be recycled. It is going to be reused, and it's going to enter different spheres at different times, and different organisms are going to be part of this. So I hope this helps, and I'll see you guys later.